All right, so it's about 1:20, so we should get started. Yeah, so here's zero-touch deployments, keeping 300 developers from having to learn about Kubernetes, which if you've done it, you don't want to. So I'm Mark, I work for Plaid. I'm sure you've all heard of us, but if you haven't, we're a digital financial solutions provider, and we let millions of people basically access their financial data in a useful and powerful way. We support banks in the UK, Canada, EU, and of course the US. And the goal is to unlock financial freedom for everyone. I myself am an infrastructure engineer at Plaid, and as you can see by my very brief resume up here, I spend a lot of time fighting with infrastructure. So, fun fact about me, I actually joined Plaid because bank APIs were so bad. I was struggling for a long time to get both Canadian and US financial data at the same point in the same app that I actually tried to build my own Plaid and then gave up after fighting with a bank website for like half an hour. And then I actually joined the company. So how do you get 300 engineers to ship code? I mean, we all know about GitHub and all that, but what does it actually mean to get to the client? So everyone sees this nice green merge button in GitHub. You click it, it's in there, you're done, except not really. There's this huge orchestration to go from GitHub to actually in front of the customer. And 99% of the time, developers don't really think about it because, well, it's not really their problem at that point. So how do you go from source code to delivered product? So what problem were we facing? We had about 150 microservices at the time, 300-ish engineers. We were growing really quickly, and our deployment pipelines were hand copied inside Jenkins. That works when you have a few microservices, but as you keep adding more and more, everyone's building up these little custom tweaks. You fix a bug, you have to copy it everywhere. That just does not scale, for any reasonable definition of scale. So we decided we're going to have to modernize this, and we're going to start building it. We use Jenkins file, more reproducible systems. So what were the principles that we established for what we had to follow? So one of them was standardization. No one got to be special unless they did the work. And once you say if you want to be special, you have to do it on your own, everyone's fine with falling in line. So there's just, here's the standard way of doing it, here's what we expect. Everyone's fine with that. Finally, we had a policy of no waiting and shared code ownership. Once you merged your PR, it wasn't yours anymore. Everyone owned it. So there was no blocking someone's deploy while yours went out. There was no having these weird service-oriented deployment orderings. Once it's in, it's production ready and ready to go. And if it's not ready to merge. And finally, the right choice had to always be the easy choice. If you made someone read a doc, it's because they wanted to do something weird. If they didn't know what they wanted, pick the right one for them. So anytime there was an option, the default was what we wanted them to do. The default is you'll have database backups, redundancies, code deploys, all of this auditing built in. If you want to turn it off, you could. There's a switch for that. You have to go read the docs to find it. If you don't, you get it by default. So what we built was this on-Rails service configuration. And the idea was developers would write a YAML file, and then we would take that, process it, and spit out what we needed to deploy your service. So we had Terraform to manage your infrastructure. Databases, Kinesis, buckets, everything in AWS shows up in this one Terraform file. Jenkins file, we spat out this little Jenkins file that controlled your deployment. It was custom to your deploy, but it was still generated by us. We would build a single Docker image from our mono repo. So just one great big mono repo, single Docker image. Everyone shared it together, and for the most part, because it's a Go mono repo, it's not too bad in terms of size. And finally, a single Helm chart. So everyone got the same Helm chart. If someone wanted to write their own, they could, but you let them look at the Helm documents for 30 seconds, they'll turn around and come back and say, the standard one is fine, please and thank you. So this is basically what our sample configuration would look like. A very simple YAML file. We ended up versioning the whole structure so that we wouldn't have to worry about any weird bugs that got introduced affecting everyone. We could roll features out gradually as people upgraded. You define, hey, this is my service, here's where I want to run it, I want this many pods. Everything that's omitted, we had a nice sensible default. If you wanted to go in and have unusual service configurations, there was a flag for that. There was an option, there was something you could do. But by default, you got the right things. And for the most part, engineers really like this. They could go in, they could tweak it. We didn't have to go handle things for them. Hey, I want to double my pod count, change a number, apply it, off you go. So from the engineer perspective, here's how it would work. They'd write their scaffold file, our processor would read it in, and then it would spit out these files that would live in their repo. So they could look at it, they could see the result, they could see the versioning, and see what the response was. And so what's in blue lived in their repo, and what was orange was basically external. So Terraform, it all backed into modules. Every module was versioned in Git. So I want version 1 of this database module, version 2, version 3. Boom, that's right there. It also keeps the Terraform file small and readable, and because we added in just tons of stuff, especially in the database module. The Jenkins file, literally that long, because the whole thing backed into a Jenkins file library that no one ever wanted to touch, which was great. Helm vars, again, we have this big Helm chart, did all kinds of things. All we had to do was write out just a handful of variable files, the variables that they needed. Every now and then people would double check to make sure it was fine, but we have this unified Helm chart. Off they went. And finally, environment variables. So we wrote a little environment variable config loader that would read that file and load it into your environment. You didn't have to process it yourself. You didn't need to do anything weird. Just a flat ini file we read in and presented to your application. So this really helped. It standardized a lot of things. People were writing more and more services. It was great, except deployments were really hard. It was easy to miss deploying a change service. So in a monorepo, there's always going to be that file or that package that everything touches and everything depends on. And if you change that, you have to deploy everything. And it's super easy to miss doing that. It's also easy to forget about deploying your services partway through. We made people approve each environment they were going through. So it's like, oh, I'll approve to 2 or 3 environments and forget about production. You multiply that by all the services, people are missing just everything everywhere. And finally, the cardinal sin, someone else will deploy this. The easy choice was to not do the right thing. So they'd change something, they'd forget to deploy it. Eventually someone comes along, there's 50 or 100 PRs of just changes. They're probably fine, but you never really know. And there's always that weird trepidation of, do I want to be the person that pushed the button? So the fix to this was build something even more elaborate. And it's just deploy everything automatically and safely. So don't wait for people to approve it, deploy it and check. So that's where zero-touch deployments come in. You fully promote everything to prod when there's a detected change. So we have a little change detector that says, these services have changed, just deploy them. But if it comes back and says everything's changed, everything's getting deployed. And the way it works is it monitors your metrics. And if it finds a fault in them, if your latency goes high, your error rate goes high, it will roll back your deployment to the previous version. So if you have a problem, it'll roll it back. And it's way faster than a person doing it. So this thing could find a fault within 90 seconds, whereas a person, minutes, maybe you have to wait to get paged, hope for the best. And we built it on the traffic shifting model. So we would spin up new pods and shift traffic to them. So if we had to fall back, we didn't have to spin up new pods, spin up the old pods again. This is sort of like a design decision. You don't really have to use something like that, but the result is you make a rollback very, very fast, and you don't need to worry about what if there's a problem spinning up my old pods. And finally, the automaticness. I can't stress this enough. If someone has to approve the rollback, they're going to forget, so do it for them. So internally, we built this on LinkerD, Argo Rollouts. Argo Rollouts is similar to Argo CD. They're in the same family of products, but they're unrelated. So you can use Argo CD and Argo Rollouts together. You don't have to. Our deployment tooling is Jenkins. Largely because it's so outrageously powerful, you can build these really complex, really powerful deployment pipelines. Might not be right for you, but for us it kind of worked. And then Prometheus is our monitoring stack. You know, you can build this on really anything you want, but we've been building on Prometheus, and that's worked fairly well. And then we wrote just a smidgen of custom tooling here and there where the existing stuff just wasn't ready, it wasn't up to snuff, wasn't doing what we wanted. So LinkerD itself is what's known as a service mesh, and the idea is it's basically a layer 7 router. So it buys you things like, you know, free MTLS, service-to-service authentication. It'll do fault injection. It can do like weighted routing. It's incredibly powerful, and I do recommend you check it out. I'm not going to talk too much about it, but it's both powerful and powerful enough to hurt yourself. So Argo Rollouts itself, so it's in the family of Argo CD, but it's not Argo CD. So it's a separate project. The CTO of the company that maintains it, nice guy, but it internally controls the development. Like it is a deployment operator inside Kubernetes, and so it will spawn pods. It'll shift traffic. Well, it'll tell LinkerD to shift the traffic, and effectively, like even if Jenkins dies, this will keep running correctly. If this dies, it'll start back up and carry on where it left off, which is actually really great. And finally, it also talks to Prometheus. So that's where it pulls in the metrics and says, okay, this metric is fine, this metric is healthy, keep going. And here we've got a little example. Like it's got a nice CLI that's nice to work with. The CLI does not work in Jenkins because, as you can see, it's far too pretty. But you just say, hey, there's how many specs I want. Here's my rollout steps, 20, 40, 60, 80. Set a pause in between, and off it goes. The manual has far more details, and I do recommend you check it out. So the rollout flow is kind of complex, and this is probably the hardest part that our engineers struggled with. So once you do a Helm apply, you get an edge detection event where you're saying, here's the new version I want you to run. Argo grabs it and creates a canary, and this is a separate service object, and it starts spinning up pods inside that. So it'll shift traffic and then just wait, and then carry on, shift more traffic, wait, shift traffic, wait, and that's this continuous independent loop. And at the same time, it spawns the metrics loop, and what that is doing, it's checking your metrics on an interval. So it's evaluate and wait, evaluate, wait. If they're okay, keep going. If they fail too much, issue a rollback alert, roll back. And the real big stickler is both of these loops are going at the same time. So they're not interleaved in any way. So it is possible to fail your rollout before your pods spawn if you configure it that way. Like if it takes too long to spawn your pods, you can fail your rollout. Finally, you get to the end, and then that's cleanup, and that's where it either deletes the new pods or the old, depending on the result. If you fail, delete the new pods. If you succeeded, delete the old. Failure, it just marks it as failure, rolls back. Success, carry on, you're good to go. And then you can have a timeout. And this is a weird scenario where it can't make any progress forwards because you're out of resources, your pods aren't spawning. The timeout problem was what our engineers had the most to struggle with. If only because, hey, it timed out, what does that mean? Usually it's some infrastructure problem, sometimes it's a problem with their pods. We just had to stop periodically and help them out with the timeout. And gradually we wrote tools that would detect, oh, it's a timeout, increase the number of nodes you have available, ping Amazon that they're out of nodes. That was a fun one to find. But yeah, we gradually fixed all the timeout problems over time. But from a user perspective, they're just awful to deal with. So for us, we had 4 kinds of services. And I suspect you're probably all going to fall in the same category. So the usual ones are the servers. If you take traffic via an ingress, we called you a server. The next one are workers, and these don't take traffic via an ingress. Kinesis, S3, database, internally generated. No ingress, no traffic, which is a real problem if you are using traffic shifting via LinkerD, because then that just doesn't work. Now we have jobs, which if you're familiar with cron jobs in Kubernetes, they run when they want, but not at deployment, so they're incredibly difficult to test this way. And then finally, we have singletons, which are you must run an exact number of pods. We've told developers don't build services like this, but there's always someone who has to. And so like, what exactly does this like look like when we're shifting traffic this way? So this is the default, this is canary shifting. And the idea is you ramp up your pod count, so by the end of the deploy, you're running twice as many pods. It's great if there's a fault, you can fail back instantly, but you double your pod count, so you're doubling your resources, which means you're probably doubling your nodes. If you're running a lot of nodes, this can put a meaningful strain on your cluster. But again, like the traffic just gets shifted over in steps by the service mesh. The alternative is this rolling traffic shifting. You keep your pod counts roughly constant, and you shift traffic via pod count instead. So this is good if you're like a Kinesis consumer or like a database consumer. You're just waiting around for data. The big advantage is you don't need to scale up your infrastructure to run this. But if you have to roll back, you have to wait for your old pods to start back up again. And you only can be as granular as your pod count. You can't do 10% traffic shifts if you have 4 pods. So what did our teams end up monitoring? Like there's the usual, hey, success and latency, but there's some other things you can actually like check on. Like because we have an integrated Prometheus stack, we could check other services for their health. So I mean, I might think my service is fine, but if the API service is failing now, that's a fault that I want to roll back on. I don't want to wait for an alert. And that's a bug that's incredibly hard to find via like unit tests or integration tests. You want to catch that in sort of like a weird way. You want to find these bugs that occur only in situ. Increases latency on responses. These come from just anywhere, but these are like really common because you can find problems with like, hey, you wrote a database query which does not scale on the production data. Finally, database errors. Someone forgot to add a column. They added it in all the other environments, forgot prod. It works all the way. Bam, dies in production. You want to grab that, roll it back. And finally, just processing rates. Like if the logging rate of your system starts dropping off really fast, that probably indicates there's like a fault, especially like ingestion rate. Are your queues backing up? That probably indicates like something's gone wrong. Maybe roll it back. So metrics are hard for engineers, and here's like two that we suggested people write. We pulled these out of like the Kubernetes default metrics, and as you can see, they are kind of awful to read. The big things to look for, the big point I want to point out is the or on vector part. If your metrics have never been emitted before, they're null, which is different from 0. And if null is greater than 0 or greater than 1 or less than 1, your metric will fail in a bad way, and people will get confused. They'll have a tough time. So this or on 0 shoves in a 0 if it's going to be null. We do this all the time. There's a metric query that was like physically too big for this slide, where we had to check to see, have you emitted data? Have you emitted data more than 0? So we don't get nulls, we don't get division by 0. It was horrifically long, but it would never ever error out or give you the wrong answer. And yeah, that ended up in the docs like, we suggest you do this. So what does it look like for the steps you want to see in production? You want your steps to be big enough that you get a meaningful amount of traffic. Like if you don't have 100 RPS, a 1% rollout is going to give you nothing. You'll get a request here, request there. Your data's garbage. Don't waste your time. So the lower your request rate, the bigger your jumps want to be so you get enough data. You also want to be watching for long enough that you know that you can make reasonable certainties about like that you're actually getting something valid. We actually have linters that say, your steps are too short. You don't even have enough time to properly evaluate your data before finishing. Make this longer. So after building this, like what exactly was the result? We caught several potential outages, partway through production or partway through deployments. They'll make a change, it'll start airing out, we'll catch it, we'll roll it back really quickly. Someone once dropped their pod count from 100 to 10 because they typoed, They wanted to go to 110, drop one of those digits, rolls out, system goes, oh, no, that's wrong, rolls it back. So that was great for reliability. On the other hand, it exposed every rough edge in the deployment system. Like every time something went wrong, it was harder. If your metrics weren't good, you felt it because your code just wouldn't deploy. A lot of teams really struggled with this because it's, they had metrics and they had alerts and it was fine, but it was only fine. It's hard to test your alerts because no one does. They weren't getting paged, must be fine. But now it's, oh yeah, we copied these alerts and now we're getting deployment errors. What exactly does it mean for a service to be healthy when you're getting one request a second in testing? So every potential weird rough edge we had, how quickly can you actually deploy? How quickly can you spawn nodes? How quickly does your underlying infrastructure react to these sorts of things? But on the other hand, service quality has really improved. We catch more problems. We roll them back before customers see them. We don't let things that would have taken down the system out earlier. So we grab them and we pull them back. And we can tell people about them. So we have postmortems. Previously, people would say, we would have caught this if we were running this tool. They add it in. And eventually you get these decent selection of metrics that say, yep, here it is. Here's the problem. Grab it. Stop it. And finally, the big win, at least from my perspective, is that code freshness has increased. There is no more, oh, I deployed 2, 4, 6 weeks ago. I'm sure it's fine. Your code is stale by an hour or two, not weeks. And so your customers are getting your code, and you can be certain that if security comes in, gives you a security patch, all your services get it relatively quickly. You don't have to chase people down, bug them to do this. So it's been a net win, but it's not without its challenges. So if you're going to build something like this yourself, test everything, because your deployment system is probably not well tested as it is now. We wrote a test that would shift traffic between a test service basically continuously, and if it dropped a single request, it would page us. So that way we could say, yeah, LinkerD will work, Argo works, Kubernetes works, we know it won't blow up. Find your early adopters. Find someone who's really keen on this. Find someone who sees the value and work with them. They'll be more forgiving of the bugs. They'll be more willing to try things out. Early adopters are wonderful. They'll give you great feedback. If you want to use LinkerD, it's not a requirement, but it does have a lot of features. Migrating to LinkerD is a lot of work. It is surprisingly hard if you've got a lot of traffic on your service, because what happens is when you inject LinkerD, the first pod that comes up with the LinkerD pod says, I'm available, ignore everyone else. So your 100, 1,000, 10,000 RPS is funneled right at a single pod, and then you go down, and down, and down. And eventually your service will recover, but 5 minutes, 10 minutes of downtime as it tries to spawn these things. We actually built a tool to duplicate our services so we could shift traffic via DNS, turn on LinkerD, and then shift it back. It takes several hours. So if you see the value in LinkerD, go for it, but it's not all free, especially if you have existing infrastructure. Now, I really recommend identifying your common service patterns. We've got ours, but I'm sure you all have what's common at your company. Find them and make them well-supported paths. Even if it's kind of the wrong way, you want to give someone yeah, we've solved your problem, here's how you do it. And then people are much more likely to go along with it and less likely to kind of drag their feet. And at the same time, onboard teams slowly. Don't say, okay, we've built this, everyone has 30 days to turn this on. Let them move on slowly. It's better for someone to have an outage and realize they could have fixed it with this than to say, do this right now. So if you want to sell this to people, you have to emphasize safety, not speed. If you emphasize speed, people will pick terrible metrics, observe them for 30 seconds, and say, my service is healthy. You want to emphasize safety, catching bugs, catching problems. In your documentation, provide good examples. We've given people, say hey, this is a bad metric, don't use it, but this is just illustrative. That metric shows up in every PR that people were opening. So we'd have to change the docs. Don't use this, use something else. Build an onboarding path. Like, starting from greenfield services is great, but I'm sure everyone has dozens, hundreds of services that you want to migrate onto where you can see all the value. You need a nice, smooth onboarding path. If it's rough, people are going to really struggle. And if people don't know where to get metrics from, because that's very common, start with your alerts. There's a lot of good data there. They're tuned through experience. You'll have some trouble, but at least you know what you care about in terms of value. Finally, the trivial metrics, just don't allow them. If someone has a completely new service, up is a fine metric. The pods are running, that's all I've got. But if you have production traffic, pick a real metric. Latency, request success, anything other than are my pods running? And finally, when someone makes a mistake, and they will, update your docs, make the examples better, tell people what to do, tell them what not to do, but put the what not to do at the bottom, because otherwise they'll copy that. So what to do at the top, what not to do at the bottom. And start with the well-behaved services. These are the services that follow all the rules, all the guidelines that you want. You don't want the service that has like custom NLB routing when everything else is on ALBs. Pick the really common ones and start there. Build a way to override metrics validations in an emergency. So we built this in and we use it like all the time because it's, hey, my metrics are wrong, the data's wrong, Prometheus is down, I have to deploy, just fire this into production. We use this surprisingly often. Like, it is an emergency thing, but it's this has to go out now. Don't check. I need to deploy this, and the metric I depend on, which is some other service, is failing. Push this code out. Finally, don't use this to test new features. You want to use feature flagging for that. If you all these deployment operator patterns have the concept of there's two versions in play at any given time, stable and canary, and when you're moving one to the other. You can't have like multiple weird versions around. It will just confuse the deployment operator. And we hit this, but sticky sessions are death. You can't round robin weight sticky sessions in this sort of scenario. So you need calls that are independent of each other. So some of the challenges we hit. Oh, still have a bit of time. Developers really aren't experts in metrics. Like Prometheus is a weirdly relational database. Like you can do cross joins in it. Don't, but you can. So give them tools, give them examples. Really lay out how to do things right. Because at most they've written some things in Grafana and it looks nice-ish. They will make mistakes here. And finally, it's like this new way of thinking. Like people don't really think, what does it mean for my service to be healthy from an innate perspective? So everyone's going to have a bit of a learning curve to get over that hump. So have things go slowly, have people onboard slowly. We have open hours when people can come and just ask us questions. Come on down, we'll explain everything. Well, to the extent that they can stand PromQL queries. And so the big complaint that people have is deployments are slower. Like you have to have these pod wait times for you to analyze these metrics. But also, you have to wait for the pods to start up. And it's step by step by step. If you need to spawn up new nodes, those are 5 minutes, 5 minutes on a good day. Sometimes that will fail. And then the canary deploys themselves can fail in ways that you don't really expect. So if you run twice as many pods, that can strain your infrastructure, especially if it's a big service. AWS can take 5 minutes. I keep saying 5 minutes, that's our benchmark. Sometimes AWS comes back and says no nodes. As well, if you launch a lot of nodes really quickly, you can knock over your Kubernetes cluster. Like we have done this, where, we need 100 nodes, they all show up really quickly, and Kubernetes just dies. We've beefed up our master nodes to deal with this, and we've slowed down the pod creation to smooth this out. But you can knock over your cluster if you aren't at least a little bit careful. And so, was this worth it to us? In the end, I'd say yes, if only because We caught several dangerous commits. Service quality's improved. We've now validated all these alert metrics. So we know that these alert metrics will fire correctly. If it's gotten out to production, it's in a good state. But like net, it was a lot of learning by the engineering organization to go from like, deploys are fine, I don't need to think about it, to like, okay, what does it mean for my service to be healthy, to deploy, to work correctly before I get to the whole, there's an outage stage. So good tooling is expensive. Like we have a team building these, and the only way you can make it worthwhile is if you standardize. So if everyone's using the same tools, everyone gets a benefit. If everyone wants to have their own custom everything, you won't have the critical mass to build tooling of this caliber. So, if everyone's off on their own, you start building something that's a little bit better, and gradually people will realize, I don't want to maintain this, I'll use the standard stuff. And then, as I said, make the right choice the easy choice. Don't let people make a mistake by accident. Require that they make it on purpose. So if they don't know, pick the right thing for them. And automation as much as you can. No one wants to think about any of this. And finally, examples should demonstrate the right choice and encourage people to read them, tell them to go there. You want like really in-depth examples, if only so that, again, you make it easy for them to do the right things. Thank you so much. We've got 5 or 10 minutes for questions. Are there any questions that I can answer? You in the blue.
Yeah. So I actually got a few questions. So first off with Plaid, let's say one of your banks that you talk to goes down and do you ever get false positives that it looks like something is wrong and someone got
Yeah. So the question was, do we get false positives from like other services being down? And the answer is yeah, you do. It does annoy people, but at the same time, you're sort of in this weird limbo state of you don't really know if your service is working correctly. Your data's coming back as like, hey, something's wrong. Internally in a service, you can try to separate out what's an internal error versus an external error, what's failable, what's retryable. If your database is down, that's probably more serious than what if one of my 15 or 25 integrations is down.
Next up, you mentioned that you don't necessarily need approvals for things. What about just automated tests? Like, is there these checks that are running in tests that before this gets pushed out to production?
Yeah, so the question was, are there like automated tests that get run before things get pushed out? And yeah, we've got like a large series of tests. There's unit tests and integration tests and lots of other things, but this is just more of like one layer of defense. So there are things that you can't catch in tests or in like lower environments that will show up in prod that you have to catch there.
And then the last one, how long did it take you to migrate onto services from that copy-pasted template into this?
So the question was, how long did it take? We've been doing this for like a few years now. It helps that like as people add new services, we just put them on the new template stuff. The older things, they were sort of migrated. If someone asked for a change, like, oh, you need to migrate to this now. We've got all of them now, but like every now and then we'd like go and like find one to like fix it. But it was a journey. Yes.
How do you handle database migration? The new version of the source code supports new schema, and you're shifting traffic in parallel. The old code doesn't know about the new database schema.
Okay, so the question was, how do you handle database migrations when you're like shifting traffic? And the way we build this is we tell people your code has to handle like version n+1. So you have to migrate your schema in parts. Like if you're adding a column, that's fine. If you're deleting a column, you have to do a bit of a dance. It's a downside. It's a bummer. I agree. Shipped code where you can like stop the service, upgrade the database, start it up is great, but you have to keep running. So we say you have n+1 compatibility, and that's the rule. Yes.
How do you deal, similar to the database question, but how do you deal with like, secrets? Like if you need a new secret, once you develop, you have a new version, you need a new secret. How do you coordinate that?
So the question was, how do we handle secrets and how do we handle like secret versions? And we've actually versioned our secrets. So we use AWS param store for most of our secrets, and it has like a version counter, and you can ask for secrets by versions. So you could have your old service start up with version 4, and your new service starts up and says, I want version 5. And what this has let us do is it has let the engineers write to the secret store. Because it's all versioned, someone screws up, doesn't affect prod. Yes? So the question was, are we using Canary deployment, just Canary, or also blue-green? So we're using both. So Canary are the majority, but we do have some services that basically need to be sort of like rolled out, like in one big lump. Like they'll just run a single pod and you just flop them over. But Canary's the default. We don't do a ton of blue-green, if only so that we can gradually see the effect of traffic. We don't have to dump it on everyone all at once. In the back, yes?
Yeah, you made reference for a couple times about some custom process that you have built into that. How, one, do you actually enforce that people make sure that these processes are followed in their own pipelines? Or two, how do you basically then obfuscate like end users to actually know that they're adhering to these custom processes?
So the question was like, how do we make sure the end users like follow these custom processes? By default, the scaffold generates the right thing. And we give people an escape hatch, and after that we say, like, you can go do your own thing. Most people get really scared when you tell them, like, oh yeah, there's the Jenkins file code, go for it, because it's all groovy. Helm file is awful.
So I guess my point
Yeah.
is there not a post-process then that actually guarantees that they attempted to use the scaffold? Or basically, we see that you didn't use it, have fun.
You know, there's like peer reviews and like spec reviews and all that. Generally, if you make it good enough, people won't bother. But if you give people the option to leave, they're more likely to strongly consider yours. But if someone really wants to go their own way, I mean, sure, it's your service, you own it. We just make tools. Yes?
Do you also do have a staging environment and you roll out directly to staging?
So the question was, do we have a staging environment? And yeah, we do, and we roll it out there. People will have like custom step definitions and custom metric definitions for each environment. Like you don't need, these really gradual ramp ups in staging because it gets 1% of the traffic. So they'll have like different metrics and things like that. Yes, back there. So the question was, have we done any benchmarks against any other service mesh frameworks? We haven't done that. We did like a feature comparison and found that like LinkerD kind of fit what we needed best. They all, every one of them publishes, their own benchmarks. Try it yourself. But for the most part, like it has basically worked out. But some people say I need the feature of Istio, or I want the low overhead of LinkerD. Yes.
Real quick, can you walk me through the change in mindset around cost forecasting? Because now you're essentially spinning up double the amount of pods for most of the days.
Mm-hmm.
So you guys adjust your cost forecasting?
So the question was, how do we adjust our cost forecasting to deal with running duplicate pods? And for the most part, we didn't put a whole lot of emphasis on that. I mean, it does raise costs, but if your deployment runs for an hour, you run twice as many nodes for an hour, okay, that's $8. Then it's done. And then you just like shut down the node. So it didn't really make a big impact. Like if you look closely, you'll see, oh yeah, it goes up during the day and down at night. But mostly it didn't. The bigger services tend to swap out pods just so they don't have to have this like constant growth and shrink. So they didn't really have a big impact. And small services like, oh no, you ran another node for half an hour. Here's 20 cents. Yes?
Did you see like an average increase then in like your total node count? Like because I mean you get like statistical randomness, like you can spread it across maybe like for your loading during the day, but then you're seeing like on average you're like 5% more node use or 15%. I mean what max 20%. I guess that's your total entitlement. But
Yeah, so the question was, did we see an increase in like node count utilization? And like, yeah, you're gonna see like a little bit. It depends like how you've configured Kubernetes, like repack your pods, because like you spin up a bunch of new nodes, it'll put things there, it'll try to repack them. It depends on like your existing spare capacity, how much it needs to spin up as well. So we don't have any specific numbers about that, if only because it gets boiled into organic growth and service growth, so we don't have a ton of data around that. But it's a few percent, probably like 5 or 10. Yes.
I Are you doing it only based on metric of time, or for example, amount of requests as well? So for example, if there's, let's say, jobs that actually like processing queue, but there is like maybe one job an hour only, so it fails only 1 hour later. It's after your like initial timeline.
So the question was, do we handle request validation just by time, or do we have like request volume? Right now we just support time. You know, several people have asked for like, I want a request volume metric because, you know, it's bursty, and that's definitely on our feature list, but we just don't support that yet. Yes?
Have you seen a decrease in like incidents around releases or the amount of engineer time spent on release? And everyone's talking about infra, but
Yeah, like so the question was, have we seen a decrease in the amount of time we spend on incidents and the duration and things like that? And the answer is yes. So like, we will catch things that would have taken us down and that someone would have had to have fixed. And you know, one of the great things is it shortens like the mean time to repair. So like, take the example where someone typoed the pod count, that would have like taken us down. Someone had like changed the pod count, spun those back up. That's, you know, 5-10 minutes if someone's really on the ball. This thing caught it within 90 seconds. And that was before before we got like the full impact as well. I'll go. So the question was, do we use HPAs or other dynamic replica sets? So some services have HPAs turned on, and the metrics do get a little weird, but for the most part, we found it's worked pretty well. Like if the HPA says, I need more pods, it just spins up more pods. And the pods get like evenly distributed to both sets. So, you know, you might spin up a little bit more, but for the most part, if you're stable at 10, you'll spin up another 10. If you're stable at 20, you spin up another 20. Yes?
I was thinking, could you tell a bit more about the dynamics between product leadership? Because suddenly I imagine people, instead of adding new features, that they're figuring out what kind of metrics should I add, and how did that impact the productivity teams? In the short term, of course. I know the long term was.
Sorry, I'm not sure I follow. Like, how did?
How was the dynamic between that type of work and the product managers who were asking, I imagine, for more features for the customer rather than adding metrics?
Yeah, like for the most part, if you say like, hey, we deliver like less buggy software. Sorry, the question was like, how do we balance delivering features versus adding metrics? Adding metrics doesn't take a ton of time, but it does take a little bit of time. But you tell people like, hey, you'll deliver fewer bugs to the customers, you'll be down less often. That's a big win for like product managers. Because even if you say, oh yeah, it fell over and repaired itself in 30 seconds, there's nothing you want to do more than go to a customer and be like, hey, we had an incident and we were down, and here's why, blah, blah, blah. If you can save them that time, they love it. So we're at time and the other group is coming in. So if you have any more questions, I'd be happy to answer them in the hallway. Otherwise, thank you so much for coming.